to add a calculator trick here, and you'll see where it might apply and make your life easier. P of x, and again, I'm referring to binomial probability distributions in particular. P of x is binom PDF, right? NPX. We've been doing this. This is what I've been doing in my binomial cases. This is the probability of exactly, so let me write that out. Probability of exactly X successes in N trials. But you know, when you guys go to your calculator, you also see binom CDF. This C indicates, and again, it's still NPX, but it's a little bit different. This C, think of C as cumulative. Cumulative meaning addition. The binom CDF does the following. P of 0 plus P of 1 plus P of 2. It continues to add probabilities all the way to whatever the heck you put here. Okay? So CDF does a sum for you from the probability of 0 up to whatever the heck X is. Whatever the heck you put as X here. Binom PDF does just X successes in N trials. CDF is going to add a bunch of different cases for you. So I'm going to use CDF, and I'm going to use the concept of complements too to make my life easier. You're going to see what happens. I'm going to use this example. I'm not going to do exercises 15 through 20. I'm just going to make stuff up. But assume that random guesses are made for 8 multiple choice questions on a SAT test, and we're already kind of assuming it's binomial. Each with a probability of success, small p, of 0.2, 20% chance that you get it right, so Q is 0.8, probability of getting it wrong. So success is getting it right, and failure is getting it wrong. Find the indicated probability for the number of correct answers. So let's just call this A. Find the probability of getting exactly 5 correct out of the 8 total. So this is a binom PDF case where N is 8, P is 0.2, and X is 5, right? So let me show you. I'll go through the calculator. 8.25. So binom PDF. Second vars. Where is it? Binom PDF. And what I say it was 8.25. 8. P was 0.2. X value was 5. So this is 0.0. Very, very unlikely. So this is approximately 0.0, oopsies, approximately 0.009 or 0.9%. I would say that that's highly unlikely that I go on a SAT and 8 multiple choice questions, I randomly guess, and I get exactly 5 of the 8 correct. That's a large number correct out of 8. 0.9% chance that that happens. Highly unlikely. We'll find the probability that I get less than 5 correct. Less than 5 means 4 or less, right? Less than 5. I'm not including 5. That means I get 0 of them correct, I get 1 of them correct, I get 2 of them correct, I get 3 of them correct, or I get 4 of them correct. This is the probability that I get exactly 0 correct. Or, addition for or, the probability I get exactly 1 of them correct. Or, the probability that I get exactly 2 of them correct. Or, addition for or, right? The probability I get exactly 3 of them. All these scenarios lie within less than 5 correct. Now, who the heck wants to do 1, 2, 3, 4, 5 calculations? I'd have to do binom PDF for this, plus binom PDF for this, plus binom PDF for this, plus I'd have to add all these up. If I'm using binom PDF, I'd have to do it for each one of these 5 times. Here's where binom CDF comes into play and makes my life easier. It does the sum for me, cumulative, from 0 up to whatever this X value is. So what am I going to do? For this one, I'm going to do binom CDF. N is 8, P is 0.2, and I'm going to want my X, let me do it another color. I want my X to be 4. I want it to be this last value in my addition. I want it to be that last value. Binom CDF is going to do this whole sum for me. Well, let's go. Second vars, down to binom CDF. Be careful you don't accidentally choose the wrong one because they look similar. Trials was, I already forgot, 8. Probability of success per is 2.2. The x value was, I was 4. Now this is binom CDF. 0.989, 0.99 basically. Approximately 0.99%, not percent, 0.99, or 99% chance. I want you to realize that you are never going to round up to 100%. 100% says that it's going to happen. Even if this is 9.99, even if it's 99.9999999, you never round it up to 100%. You're always going to keep it as 99.99. Because if you do state that something is 100% chance of happening, then it has to be true. It's going to happen. And the only way that that is true is if, you know, you're using, if you are certain that it's going to happen, if it's a certain event. All right, let me do one more, or maybe a couple more. Same scenario, right? N was 8, P is 0.2, Q is 0.8. And this is part C. Find the probability that I get less than 3 correct. So find the probability that out of the 8 I get less than 3 correct. That means 0, 1, or 2, right? So since I want to add up multiple probabilities rather than doing binom PDF again for each one of these, I'm going to use my binom CDF. N is 8, P is 0.2, X is going to be the last thing that I want to add into that. If I'm using CDF, cumulative, it's going to add it for me, right? Don't forget that. So let me do that. Second vars, binom CDF, and the only thing I'm changing down here was 2. I'm assuming the probability would go up. Let's see. Sorry, down. Approximately 0.797, 79.7% chance that I go to this test, I guess on all 8, and I get less than 3 correct. That would make sense. That's a high probability. Now I'm just playing with the binom CDF, so let me do one more. Find the probability that I get more than 6 correct. More than 6. Now there are 2 ways you could do this. More than 6 means 7 or 8. This would be a binom PDF for 7 and binom PDF, that's an 8.2 for 8. Let's see what I get. I'm going to do it 2 different ways. So second vars again, binom PDF, N was 8, P was 0.2, and I want X for the first one was 7. And then I'm going to do plus the situation for 8. So I have to do binom PDF twice, don't I? And then for 8 successes. 8.44 times 10 to the negative 5. That's really small. So I'm just going to write that as 8.448 times 10 to the negative 5 because I want to just show you something. I'm going to claim that it might be easier to do the complement. Now, the complement of that because 7 and 8 is 7 or above, right? The complement of that is 6 down, isn't it? And if I'm using the concept of complements, I have to take the complement and subtract it from 1 to get the same thing as 7 or 8. But why am I claiming that this is easier? There's so many more probabilities involved here. All of this can be found by doing one binom CDF, 8, 0.2, where x in the binom CDF is the last thing that I want to add up in there, in this case, 6. So because binom CDF does this specific type of calculation, it makes it easier to use the complements here, even though there's more probabilities involved. Now, either one works. It's all dependent on what you like and what you prefer. I'm just doing it 2 different ways. Oops, I want to show you the whole thing. 1 minus binom CDF, where 8 trials, 0.2 is the probability of success, and the x value, what was it? That was that last one. 6, right? Is 6. And I get the same exact thing, 8.44 times 10 to the negative, using the concept of complements. Now, obviously, both of them work. Which one is easier, which one is faster? Obviously, it also depends on the situation that you have. It depends on a preference. It depends on the situation that you have. You know, it depends on if you mind doing PDF twice versus one CDF. It just depends on what you have. So I wanted to show you both scenarios. Like I told you, complementary events, very important concept. You use it in a lot of different places in statistics and probability. And you can see that it makes your life a little bit easier for certain types of calculations. And it all depends on the situation that you have. In this situation, the concept of complementary events did help me, because then I just did 1 binom CDF instead of 2 binom PDFs. Anyway, depends what you like.